I'm Elias Karapanos, Senior Asset Manager in Water Resources at Affinity Water.
Ilias, perhaps you can just explain to our listeners where we are, and thank you for talking to the Affinity Water podcast series.
We're standing next to the River Cam. It's a catchment where we take groundwater from, so we're monitoring groundwater levels, river flows, and the ecology to understand the impact of our abstraction on this river.
Let's just walk further down the river and see what we can see. There's a bridge coming up, I believe.
Yes, there's a bridge coming up. We're going to cross the River Cam again over the bridge, so we're going to have a look at the river flows there.
And one of the things our listeners and our customers may be confused about is whether or not Affinity Water has a hosepipe ban at present, and whether it will in the future, because other water companies have got bans.
That's right, so some water companies have put temporary use bans, or hosepipe bans as we call them, in order to keep the demand as low as possible. Affinity Water haven't, because they are groundwater dominated rather than surface water dominated like some other companies are. And as this particular drought has evolved to date, it has impacted surface water systems more than the groundwater systems. So for 2022, we have decided not to put a hosepipe ban because there is no such issue at present.
And going into 2023, we're only a few months away from January 2023, what will the situation be? Can we predict?
Well, it all depends on the winter rainfall. So this coming winter, we expect to see average or above average rainfall in order to see significant recharge to take us out of the drought situation, if you like. The groundwater system responds to winter rainfall, and the chalk aquifer in this regard. So it is heavily reliant on the rainfall over the next couple of months up to around about March, where the recharge window typically closes. So if we have seen significant recharge between now and then we are likely to start the seasonal recession over the spring and summer from a higher position overall. If we don't, then in a predictable way, we are likely to introduce restrictions next year at some point.
And if we just look at the river, come a bit closer, Ilias, as you said when we got here, there's a lovely bridge, but a really nice river flow.
At this time, although groundwater levels are lower, below average for the time of the year, and river flows have followed suit, there is an element of river flow that comes from groundwater, which is what we call base flow. So that responds to seasonal changes in groundwater levels. But obviously in every river there's different types of flow. You can have runoff, so following rainfall you can have the rapid flow, runoff. You can have other discharges going on, so several things may be happening in a certain river. We are putting a lot of monitoring to understand what is what and what is to be expected at any time of the year.
Thank you for that. Just to clarify, is that a chalk stream?
It is. This is the River Cam. It receives water from the chalk, either directly or indirectly. Obviously the geology in the River Cam can be different in different places, but there is a certain element of flow that comes from the chalk.
Well, let's just listen to that river flow. And if we walk a bit further along the river, Ilias, with you, there's more algae on the river. It's stiller, quieter.
Yes, so the combination of high temperatures, especially over the summer months, and the below average rainfall consistently since the start of 2022 has contributed to this situation where we have eutrophication or algal blooms, as you mentioned, and a lot of surface water systems have turned green from the algae, unfortunately.
Right, well, let's just walk off. Let's see what the river's like a little further along. Okay, well, let's just walk a little bit to this curve in the bend. And as you say, we're by the side of a lovely river. Do we take water supplies from this river?
We do not take river water from the River Cam as such. We have groundwater abstractions in the Cam catchment. So we take water from the chalk aquifer below our feet, and this water under certain circumstances may end up in the river and provide additional flow. But we are monitoring to understand that effect, the impact of our abstraction on river flows, at certain periods, at different seasons, during high and low groundwater levels, because the whole system is really dynamic.
It's also true, isn't it, that in September, last month, just past, that there was a lot of extra rain. So it's looking quite hopeful that maybe 2023 will replenish in terms of our water supplies and underground supplies.
Well, although September 2022 rainfall was very welcome, of course, it was actually at or just below the long-term average. So we need a lot more than that for the next coming months, consistently at average and above average rainfall, to make sure that, first of all, the soil moisture is replenished, because at the moment the ground is very dry. So that demand for water, if you like, the soil moisture needs to be full so that aquifers do see significant recharge. If we don't see that, and it's patchy rain here and there, 1 month here, 1 month there, then we're unlikely to see significant recharge.
One of the accusations that people level at water companies is that they haven't invested enough in the future. There should be more reservoirs and they should concentrate more on supply rather than customer demand. What's Affinity Water doing?
Well, we're doing both. So we are trying to help people understand how much water they're using through metering and so on. We are trying to reduce the demand as much as possible and bring it at least down to the UK average of 142 litres per person per day. At the moment, for instance, in our central region, the per capita consumption is 152, so that's higher than the UK average. But at the same time, we need to look at supplies, as you say. So bringing more water into this area, or using the water we have here in this area wisely, in a way that we can supply people and also help the environment to recover. So it's a twin track approach. You mentioned reservoirs there, which is one way of getting water in. Now obviously a reservoir it creates more storage, but where it is, how it is refilled and all of that needs to be carefully looked at, and then how the water is transported into our area also needs to be carefully looked at. We're working with a number of water companies, neighboring water companies and further afield, to understand how we can use our water resources wisely, how we can move water around in the most efficient way. And there are big schemes coming up, and we're looking at a number of schemes as part of our water resources management plan. So obviously for the reservoirs, because of the lead time to build a new reservoir, we need to decide a lot earlier than needed. So we look at projections based on population growth and so on, to understand when we're going to need a new reservoir or a new source of water, and then see how that can be brought into our supply system. So it is a bit of both, but at the same time, I need to say here that we need to have both surface water sources and groundwater sources to help us deal with any type of drought that comes our way. As you know, climate change can cause different systems to respond differently. I mentioned earlier about the surface water systems responding to the drought now much faster than the groundwater systems, aquifers. So we need to have both in what we call a conjunctive use system.
And that's something perhaps the public or even our customers don't understand fully, because the science of water and water abstraction is often misquoted.
Absolutely. So we need to understand the groundwater systems a lot more. The surface water systems perhaps are better understood and can be managed. However, again, with the reservoirs, you have a fixed volume of water in storage, and then the matter is how quickly you can replace that and how quickly you can draw that down. With the aquifer, it's a very different system, because water moves anyway, whether you abstract it or not. It moves from one block of rock to another. So the whole issue of groundwater abstraction, how much water you take, when you take it, whether that water will make it up to the river or not, or under what conditions, is a very complicated matter. So I think we need to put a lot more science, and that's what we're doing at Affinity Water, to understand how aquifers work, when those impacts materialize, at what points, and how we can use groundwater resources in an environmentally friendly way.
And you are a qualified scientist. People don't understand just the degree to which within Affinity Water or water companies more generally, that the staff are fully qualified. They're scientists. They understand this and they want to, as you've just said, know more.
Absolutely, yes. We are putting a lot of effort into this. The people in the team are highly qualified hydrogeologists, hydrologists, environmental scientists, ecologists, and so on.
You are?
I am a hydrogeologist. So it's understanding the groundwater science, how water moves through the ground, and then understanding that relationship in the vertical scale. So the million-dollar question is always how much water that we abstract from a certain borehole will make its way into the river and under what conditions. So that's the main question we are trying to answer and understand, because we realize that through our recent studies that the chalk is a complicated aquifer. It's a stratified aquifer, it is not a bucket as we thought previously. So we need to understand those interactions in the vertical scale a lot more so that we can fully quantify the impact of our abstraction on the environment.
And if we look at the river now, what are you thinking? You've just commented on the algae on the surface.
Yes, so the high temperatures over the last couple of months have contributed to the algal blooms. We have algae in various surface water bodies, as well as in some places rivers, like in some parts of the River Cam. It's a combination of dry weather, below average rainfall over a couple of months, with high temperatures has led to this situation where you have eutrophication.
And what about the public? Now, we've mentioned how committed the employees of Affinity Water are to understanding more about rivers and the impact of abstraction and the need to plan for the future, and not least, as you've said, climate change and global warming too. But the public, does their water use make a difference to the rivers and the state of our rivers? How can they be stream savers?
Basically, everybody needs to play their part in this, because we only abstract water and come to that groundwater that we need to put into supply. So if people use less water, then we will abstract less water from the ground, and at certain times this water will make it to the rivers. Now remember, this is not a direct one-to-one relationship, but if we all do what we can to reduce our demand for water, our personal consumption, then that will help us leave more water in the environment, and at certain times this water will make it up to the rivers so that there is more base flow in the rivers.
Yes, and the Affinity Water Save Our Streams campaign has communicated to customers, and they've definitely got behind it, how you can save water at home and in the garden. But you mentioned global warming and Affinity Water's Water Resources Management Plan that's out for consultation. But how will global warming impact our water supplies, and how does the Water Resources Management Plan address that, Ilias?
There is a section in our Water Resources Management Plan, on the supply section, that talks about climate change and how this may impact on our water resources. So we are dealing with basically various weather data sets that may come our way over the next 75 years or so. And there's a lot of projections. For instance, we're looking at 400 different climatic data sets that could come our way. And there's a combination of rainfall, evaporation, transpiration, temperatures, intensity of rainfall, and so on. So all of these factors can lead into different recharge in the aquifers if we're talking about groundwater systems. Now, these different recharge patterns can cause changes to the baseline groundwater levels. The way the water gets into the aquifer can also be affected. How much water gets into the aquifer at certain times of the year can also be affected, and all of that can lead into a certain supply deficit, if you like. So we're forecasting as a best case, worst case, a certain amount of water that may not be available to us in the future. We're talking about up to 2100 now.
And we are actually using citizen scientists as well, because people are getting involved in management of the water in our rivers, and citizen scientists can be helpful.
Yes, it can. We welcome every piece of information, every piece of knowledge. We have certain groups, people who are interested in contributing to science, and they're out there, whether it's taking photos, fixed point photography, measuring flows, doing ecological sampling, and so on, to help us understand and fill those gaps in the data so that we understand how the surface water systems, the rivers, respond to the different climatic conditions. So all of this data complemented with our data and other organizations, data regulators and so on, can really help us put the picture together as best as we can and understand what is going on.
Well, let's walk, and thank you very much indeed for that scientist's knowledge that you're imparting to us on our water supplies. How committed are you as an environmentalist, Ilias? You care about this?
Absolutely. I mean, all the people working in the team, including myself, have dedicated a number of years for research and so on. So throughout our academic studies, we have put our passion into this, and now we are hands-on. We are trying to resolve real problems. We are trying to understand how the aquifers work, how the rivers work, how they interact under different climatic scenarios. So we make the best decisions, the best water resources management that we can.
Thank you. Let's walk on a bit. Wow, it's a bit bumpy, but never mind. We're just walking beside this lovely river and coming up to the bridge. Ilias, let's just end our podcast where we began it, by the bridge, with that lovely sound of trickling water again. Let's hear it. And the water resources management plan that Affinity Water is putting out to consultation, we do want people to respond to it.
We do, absolutely. Everyone can go in and submit their opinion about our water resources management plan. We plan ahead for the next 75 years, so up to 2100, based on forecasts for population growth and so on. And we say to people, this is what our demand situation is going to look like, and this is what our supply situation is going to look like. What do you think about our plans overall for people and the environment?
Thank you.